Hello and welcome. In this lecture, we're going to be creating a new component in C++, this trigger box, which will report to us when we step inside the alcove or we place any object in the alcove. You can see we're getting a little blueprint message up in the top left-hand corner. And to do that, we're going to have to understand how overlaps and blocking and different collision responses behave in Unreal. Let's dive in and find out. Now, we've already become familiar with how trace channels work. We know that you can have trace responses on the different objects in our scene, such as this shrub here. You can see that it has an ignore response to weapon traces, but it does block visibility traces. Then there's this bulletproof glass example. It blocks weapons but allows visibility through, and a brick wall which blocks both. So you can see how this system works with trace channels. Now, what happens if we're trying to decide which objects can overlap with each other, which ones pass through, which ones block each other? That can get a little bit more complicated. We saw this already when we tried to get the gargoyle to overlap with our pawn. Now, this is how it works. Essentially, we use these object types. Each object can belong to, can be a particular object type, and this is different to the kind of type system in C++. These are collision types. So you might have object A and object B, and in their settings, if we go and have a look at the settings on our gargoyle, for example, you can see that they have their own object type. This one is a world static object. But then further down, they have their responses to other types of object as well. So you can see that this object will block other world statics. It will block other world dynamics. It will overlap the pawn types. It will block physics bodies and pretty much block every other type. And obviously, the pawn itself, if we go and find our BP player and look in its capsule component, look at the details and scroll on down to where it's got a collision preset. If we can expand out the pawn collision preset, we can't edit it, but we can see what it's doing. And you can see that it has its own response to world static. So its response to the world static would be to block it. So we've actually got two different options here. The pawn is saying, I block world statics, but the gargoyle is saying, I overlap pawns. So what should happen? Well, this is where this table comes in, and I've got a link to this blog post if you want to read it in full in the lecture resources. So you can see that it takes the least blocking interaction between the two. So if object A was the pawn and it's saying, hey, I should block that gargoyle, but the gargoyle's object B and it's saying, hey, I should overlap that pawn. So it's going to take the least blocking of those two and it's going to overlap. So it does mean that if you want two things to block each other, they both need to agree that that's what they want to do. So let's look at another example here. We've got the player, which is of object type pawn, and its object response to other pawns is to block them, and the world static objects is to block them. The brick wall is a world static object. It can block pawns and block world static. So these two would agree with each other. Now the shrub is also world static, but it overlaps pawns. This is very much like our gargoyle, but it blocks world statics. So if you go down and have a look at what would happen is the pawn would try and travel through the bush, and it could because it takes the least blocking option, which is overlap, and it generates an overlap event, which we can hook into in code or blueprint, whereas it won't be able to pass through the brick wall, and it generates a hit event, again, something that we can hook onto in Blueprint or C++. So why do I go into all of this depth? Because what I want to do is put an object that is basically invisible inside this wall that allows us to put the gargoyle in here, and we get an event when that happens. So the gargoyle will prop up an event and say, hey, I've got something overlapping with me. So why is all of this important? Because I want to put an object that's invisible but will overlap with the gargoyle and let us know about that fact. We can then query it from C++, or we can get events in Blueprint either way. And the way we're going to do this is, first of all, create a blueprint from this dungeon wall. So I'm going to click the Blueprint button in the Details pane, create a new subclass, and I'm going to name it BP_. secret wall, and we're going to hit select to create it and dock it to our main window. And it's got a mover on it. What I also want to add in here is essentially a component which is called a box collision. So if we click on a box collision, you can see it's completely invisible. It just gives you some box extents, which we can change. We can make them larger so that anywhere we place the gargoyle in this box, it's going to accept it. And we can see that it has got collision options down here. We've got an overlap all dynamic as the default, but as the default preset, but if we hit custom, you can see we can change the object types and we can change how it responds to different things in here. And I think most importantly, as you can see, it's set up to overlap with most object types, which means that even if they're not set to overlap with World Dynamic, it's going to overlap. It's not going to block anything. It's going to let us position the gargoyle in here. So I'm going to go and delete that component from the scene, because what I want to do is create a new component in C++ based off of that box collision. Now, I just want to show you that with this box, if we set it back to the default preset it was on, which was overlap all dynamic, I believe, and we check, or as is already checked actually, generate overlap events is already checked, then we can go over into our event graph and we can right click in here and look for overlap, and right at the top you can see an add on component begin overlap for the box. So if we click that, and actually let's rename the box component to trigger area, like so. Then basically if we overlap with the trigger area, we're going to get a list of properties of the thing that's overlapping with us. So we could take the actor that's overlapping, we could get its name. So get display name is the name of the node, and then we could take that and print the result string and hook that up to the execution pin, and we can go ahead and hit play. And if we walk up to the area, you can see that it's saying the BP player is the thing overlapping it. Now I can't see that area because it's so dark, so I'm just going to go to the secret wall again, BP, and I'm going to add in a spotlight component, which I'm going to place in this little alcove, rotating it face down and illuminating the space where we want the object. Now in the scene we can see it very clearly, so let's go ahead and hit play, and we can walk up to that alcove. If we overlap it, it says there's the BP player overlapping, and we can go and grab our gargoyle from this cell using our newly minted grabber. And we can take that gargoyle and place it in this area. However, it doesn't seem to be generating any overlap events. And that's because just like there's two parties to the collision, there's also two parties to generating overlap events. So just because we have it enabled on that box component doesn't mean that the gargoyle moving into it is actually going to alert us to any overlap events. So what we have to do is we have to go to the gargoyle and check its generate overlap events as well. So then the overlap events should happen. Let's go and pick up the gargoyle, take him over to the alcove and stick him in. And now we are getting an event coming up when that happens. The gargoyle statue is indeed being registered. Now, I don't want to be using blueprint events in this particular case. So what I want to do is take our trigger area component and actually turn that into a C++ component that can evaluate whether it's got the gargoyle statue it wants or not already in it. The way we're going to do this is we're going to go to the add components, create a new C++ component, and as the parent class, instead of choosing act component or scene component, we're going to go to all classes and we're going to search for the box component instead. And you can see there's shape components, box components, the one we want, and we can go ahead and hit next. So I'd like to challenge you to create this component now that I've shown you how to set the parent class. So you're going to name it trigger components, and you're going to have to copy some things from the other components we've created because it's not set up in the same way, seeing as we're deriving from a different parent. You're going to have to copy the uClass line. That whole line is basically empty on the trigger component as you will create it. So copy that from either your grabber or your mover, and otherwise you won't be able to add your components into your blueprints. So then you should use this new trigger component to replace our current box component and print something from begin play. Again, begin play won't be set up automatically for you. So you're going to have to copy from the header file and C++ file of our other components in order to set it up. Pause the video and have a go. Okay, welcome back. So I'm going to call it the trigger component, all one word, and hit create class. So as predicted, our uClass line is got nothing inside the parentheses. And if we go and have a look at our editor and go to the BP secret wall, try to add this component and search for trigger, you can see nothing comes up. And the reason for this is if we went over to our grabber.h and had a look at its uClass line, you can see that there's a bit in here that says blueprint spawnable component. So crucially, we need to copy this. It also has a class group. We might as well copy the whole thing because this allows us to create this component in Blueprint. So we can go and paste this as the uClass line for the trigger component. And then the other thing, if we go to Grabber, you can see it's got begin play. It's within a protected section, and we can just copy the definition of that begin play function, copy it over into our trigger component, and put it as it was in the Grabber, just underneath the generated body. Then we can go into our Grabber CPP and see how begin play was defined in here. You can see that it has this call to super begin play. That is actually important. So we're going to copy that, go over into a trigger component CPP, and we're going to change the uGrabber : to uTrigger component begin play. And then in here we can put in our ulog. And we're just going to write a simple message such as trigger component alive. We'll go ahead and compile. This may take a little while, seeing as we've made some fairly significant changes to our header file. And once that's done, we can go into our BP secret wall, go to add and search for trigger. And in here you can see we've got that trigger component. We can now add that in. We can remove our trigger area that we've set up previously. Just go ahead and delete that and check. Yeah, we want to delete it. It's going to basically invalidate this event that we created. And we can check that the collisions are set up as we want on the trigger. If we go and have a look, yeah, it's set to overlap all dynamic and to generate overlap events. And finally, what we need to replace is this event here, where we're going to select our trigger, right click, and go to unfurl the add event for trigger, collision, and add on component begin overlap. That's what we were using before. Hook up the actor pin and hook up the execution pin too. Head over to the dungeon level, go and pick up the gargoyle, try and stick it in the alcove, and we notice that's not working. So now we've got that trigger set up. Let's go to the viewport, and you can see that actually the trigger hasn't been made big enough. We haven't positioned it correctly. So let's go and position it in the center of the alcove, and let's increase the box extent properties so that we catch whatever we've put inside this alcove area. Doesn't matter if it is a little bit bigger and gives us a safety margin. Then we can go into the dungeon, hit play, and then step into the alcove, and sure enough, it detects that the BP player has walked into that alcove. Great stuff. In this lecture, we've learnt all about object types and object type responses, and we've used that to set up this trigger component. I'll see you in the next lecture.